Monday, Tuesday, Wednesday, Thursday, and Friday. Oh no, Mr. Hall, not the quiz. That's right, my friends, your quiz. Welcome to another exciting edition of Mr. Hull's virtual classroom. I'll be your friendly host, as always, Mr. Hull. So, my dear sweet friends, if we can take a little look back where we were earlier on, we did sections 8.1 and 8.2 Thursday. And so, if you guys will remember, we did solving geometric angles and using them as applications. So, we're going to kind of build off of that. And you guys have solved this from, I would say, early on as kindergarten using polygons, just different sides and shapes, but we're going to kind of get a little more intense. So if you want to follow along, we're going to be on pages 340 to start. And I want you, if you would, take a little gander at your polygons on your planes. Here you got a triangle, which is how many sides? 3. Quadrilateral, which is how many? 4. Now tell me something else. What's another four-sided figure that everyone's most common with? And don't mind my amazing drawings. I don't want to make you guys jealous, so I mess up on them sometimes. But yes, a square or rectangle. And as you guys can see, so on and so on. You got hexagon, heptagon, octagon. What does most people relate an octagon to? Stop sign. So that's an 8. Alright, so let's take a look at example 1. And again, familiarize yourself, if you would, on page 340 with just the different types of polygons and the number of sides, and just check out the examples going along with them. Alright, so number 1 here says on example 1, it says identify each polygon and classify them. Alright, well, let's look at A. One thing I do want to remind you guys of is if you have something that looks like this, that is not a closed polygon, therefore it is what? It is not, it doesn't have a segment, so it's not even a polygon. So figures A are going to be a polygon, and figure C, because they are closed. What about figure D? Can somebody tell me anything about that? Is figure C? Figure C, it comes to, kind of looks like an ice cream cone, so it wouldn't even be classified. One thing I want you guys to also look at, if you would, is well, your skill checks really quick. It says, which of the following are polygons? Well, let's see. We're looking for sides. So segments, when I say sides, I mean segments. See, this has 1 segment, 2 segment, 3 segments, and 4 segments. If you look back at example 1, when we had the ice cream cone, we had, and I'll change color here so you can see, we had these segments, but if you notice right here, it was not. So that's kind of the same thing we're trying to look at when we look at skill check 1. It says, which of the following are polygons? So, would A be one? I would say it'd be fair to say A isn't, because let's look, it's got our little, kind of like a mouth looking thing. So, if it had went like so, then yes, it would have been a polygon, but it doesn't. So, is A a polygon? No. What about, let's look at B. What does B got? Well, B kind of looks like a triangle to me. How many segments? Are they all closed? I see 3 segments, so yes, B is a polygon. What about C? Well, C kind of has like a kind of weird abstract structure too, doesn't it? So let's just go ahead and draw it. We have, and again, I know my drawing's awesome, so it's not making me blush. So, it looks like we have segments and endpoints that we can put on here, so would it be considered a polygon? We got 1 segment, 2 segments, 3 segments, 4 segments, and 5 segments. So yes. What about D? Well, D does nothing, so Does it come to a close or does it have an end? And no, 'tis not a segment. You guys are killing this. Man, you guys are just making me proud. Yeah, alright. We're doing amazing here. Okay, so let's go ahead and move on and talk about some other kinds of polygons. So a regular polygon are something that you guys are familiar with when we talk about triangle, square, octagon. Again, sorry. Yeah. Whoa. Fail. Let me take another stab at that. But I'm trying to get 8. I am so sorry, I cannot draw a polygon. Apparently, but that is supposed to be an 8-sided polygon. And that should represent a regular polygon. Alright, so one thing that we dealt with last time too, we were talking about vertexes of polygons, and we dealt with, you guys saw this last time. Kind of look like tic-tac-toe. But remember I told you about the vertexes. This would be a vertex. This would be a vertex. It's the point where they cross. So if we look at a vertex of a polygon, it says we have a common endpoint. So with that being said, that's triangle would be an easy one to look at because we have 3 points. And since there's 3 points, that's probably a good indication we have 3 vertexes, because what that means is a vertex basically is a place that can be split in half. Alright, with that being said, let's look at example 2. It says classify each polygon. Is it regular? How many diagonals can you draw from side to side? So that means anywhere that you see a point that we talked about earlier. So I want to attempt to draw this. Let me just erase this little tail here. Alright, so let's just say we got 1, 2, 3, 4, 5, and 6. So we got 6 points, so that should tell us that we should be able to make 6 diagonals. So that we can do from here to here. 1, 2, 3, 4, 5, 6. And if you'll notice they crossed up a little bit, that's perfectly fine. But the concept is, it's like wherever you have your vertex points, that's how many diagonals can go, because each diagonal comes off of a vertex. So for me, like I like to use triangle because I can draw them. But that's 1, 2, 3 vertexes, so it should have 3 diagonals. Also, I apologize, my sinuses are pretty much killing me, so here we are. If it ain't corona, it's your sinuses. Alright, so let's go ahead and take a gander now, if we could, at example 3. And one thing I want to also touch base and tell you guys is, you want to realize the interior angles, which is the measure of most regular polygons, are 360 degrees. Alright, so that means from side to side of a square, the inside of it, all this would be 360 degrees. Okay? Now, triangles are a little different. Triangle interior angles are actually 180, some of them. So that means whatever, let's say if you were given this triangle here, and you were given 50 and 50, well, this other side has to be 80, because the sum of it has to equal what? You said it, 180. Man, you guys are killing this. Alright, so venture on with me if you will. Example 3 says, what is the measurement of angle A in the triangle we have ABC? Well, what I just told you guys, we have our triangle. We're given that B and C, B is 89. And when I'm talking about that measure, it's this measure right here. C, the measure right here, is 44. Alright, so if we were to add those together, and that means we would take the number 89 and add to 44. So 89 plus 44 gives us 133. For the measure of these two. That means whatever's left right here has to give us 180. So we need to take 180 minus 133. So let's take 180 minus 133, and it should give us 47 for the unknown right here. So a quick way to check is we can go back and add these together, and if the sum of the interior angles equal 180, that is correct, 180, then you have found the sum of your triangle. Alright, so let's move on to example 4. It says find the measure of the quadrilateral. Quadrilateral has what? 4 sides. I know theirs looks a little different, but I'm pretty good at a triangle and a rectangle, so I'm going to do rectangle here for quadrilateral. So let's go ahead and write down the numbers of the angles we're given for. We got A, B, C, and D. So that means we have points here. Point B, point C, point D, and point A. And they also have vertexes. That means 4 diagonals if you were to draw them. 1, 2, 3, and I'll put a different color so you can see that. 3 and 4. Alright, so we're given the sum of these angles here too, so let's go ahead and so the sum we're given for B is 95. The sum we're given for C is 80. The measure for here is 76. So someone want to tell me what they think we do next? Add them together and see if they equal 360. Well, my goodness, that's pretty close. Let's try and see what we got here. 95 plus 80 plus 76 gives us what? 251 for the total of the interior angles that we know. Doesn't give us quite 360, so we need to subtract 360 minus what? 251. And what does that give us? 109? Well, guess what, friends? Angle D is 109. So for quick reference, if you want to see if your measures are correct, how do you go about doing it? You go back, add all your interiors together. So that should be 1, 2, 3, 4, and the whole thing should equal 360 degrees. All right. Well, with that being said, my dear sweet friends, let's go ahead and try, if we could, example 5. Example 5 says for us to find the sum of the angles of an octagon. All right, here we go. We know that we're going to have some diagonals, correct? So one thing I want you guys to look at is, it says the sum of the angles of an octagon. How many sides are in an octagon? 8. So we need to go ahead and set it up like this. And I'm going to attempt my very best to draw an octagon. Let me just erase this right here. Not bad, not my best, but not the worst. All right, so let's go ahead and see how many points we got here. 1, 2, 3, 4, 5, 6, 7, 8. That's pretty close. All right, so that means that we should have how many diagonals? And one thing that you're going to notice here, that this actually will form triangles. And what I'm saying is like, so you can actually go from here to here. You can go from here to here. You can go, and again, if mine was a little more the way it's supposed to look, it would make a little more sense. But what I'm saying is you already know the interior of a triangle. So if we actually have the sum of the angles of the octagon, we're going to have n equals 8, because that's the number of sides. N will stand for number. And then it says find the number of triangles that are formed by drawing diagonals from the vertex. And again, that's what I was trying to show you, and I apologize again that my drawings aren't the greatest, but this right here will actually show you, this is probably the only triangle that I can actually form, if you will. There should be 6 of those inside of here. You know, what I'm saying is, if you move this here, should form a triangle. Here should form a triangle. Here should form a triangle. Here. So that means it's 3 and 3, which will give us 6. So we're doing n minus 2 equals 6. And so if we have the sum of the triangle, the 6 that we found, times the interior angle of a triangle, which is 180. If you multiply 6 times 180, well, if you do 6 times 18, or you can do 180 at first, doesn't matter, but we'll do 6 times 180. It gives us 10,000. I don't know why I put 10,000 when I clearly meant 1,080. And 1,080 is the number that we find when we find the interior of the vertex of the triangles. And again, I apologize because this might seem like a little overwhelming, and I wish I could be there in person to show you, because it would definitely be a little easier, and I could reference some stuff from your book a little better. But thanks, Corona 2020. Jeez. Loser. But with that being said, my dear sweet loved ones, we are gonna muscle through this together, and I just want you guys to give it your best effort. And as always, you have my information. So you want to get a hold of me, your parents have my cell phone, my email, just all my contact information. If you want to do video chat, we can work something out, like, for sure. With that being said, though, I do want to go ahead and hook you up with your homework. And you'll be able to, I'll also email you your, email, because you guys can't pick up Monday. I will be emailing you the rest of your homework assignments through the week, and you will have a quiz, but I'm going to, since this is going to be a little more difficult, I am going to allow you guys to have a little extra time to work on it, so I want to hook you up with 2 days, and you guys are welcome to use your book, because I know that just having videos, you know, is definitely a good resource, but I feel like as long as you're putting forth the effort to look in your book and search out some of the material and some of the answers, then you shouldn't be punished but rewarded. So, for your homework, what I'm going to be doing for Monday is going to be a continuation from page 336, 23 through 43. But on Tuesday, I'm going to have you guys do what we just worked over, and it's going to be page 344, and you'll do 1 through 16 all. Well, it looks like we have ran out of time, guys. And thanks for sticking with me. And hopefully I'll get to see you guys soon. Praying for you guys each and every day. And we're going to go ahead and sign off. And this has been your friendly neighborhood virtual teacher, Mr. Cody Hall. I'll see you guys later.